Okay, so we studied about the types of bond, and we know about the chlorine, for example, and about sodium chloride. Let's think about this, okay? Just as general example. Chlorine, this element is non-metal. Do you agree with me? Non-metal.
Yes.
And this is also non-metal. So this we have to figure out for each compound. And here, sodium, we have metal. And we have here non-metal. And for chlorine, we have just negative. Okay. And here we have negative. Okay. I want to ask you, do you know this is I don't know what is it, but when you play with a friend and just you have to stretch him to your side, or he to stretch him to your side. This is the different opposite forces that you are doing with a friend. When the forces are equal, okay, if the forces is equal, so this compound is non-polar, okay, because here negative and negative, so the forces are equal. And even chlorine itself has the same electronegativity for chlorine, this one. Far away from the electronegativity that we are going to study it, chlorine has the same properties as the chlorine as the other element, which is the chlorine. So this is non-metal and non-metal, and even both are negative. Which one of them will attract the other? There is no attraction between them. They are make sharing. If you still remember chlorine didn't transfer the electrons to the other chlorine. What she did, just share the electrons with the other. Do you still remember this or not? So chlorine with other chlorine did sharing. She didn't give her. Didn't give the other atom. So this sharing make it from it non-polar. While if we come here to sodium and the chlorine, sodium is positive and the chlorine is negative, and the chlorine has more electrons in it, so it attracts the sodium. Sodium transfer electrons to give it to chlorine. So here we have a difference in the positivity and negativity. And if we are going to draw it, we will draw it this way. This is the sodium, if you remember. This is the sodium. And the chlorine, it will be smaller than it. This is the sodium, okay? So this is less than this. This is the positive one, the sodium, and this is the negative, which is the chlorine. So there is a difference in the strength. Let's imagine it at the difference in the strength, but here is the difference in electronegativity, okay? So we will feel that there is no equal. When there is no equal, so there is polarized. They are polarized. So we say this is the apolar bond. Is it clear a little bit? Did you understand why we call this polar and that one is non-polar? This is because of the difference in the difference in the positive and the negative. Okay. So for example, if I have carbon and I have oxygen, okay, or I have whatever. Here, will act as electronegativity, and this is as electronegativity. So still negative by negative. So no one is making a force over the other. So they will be non-polar. So the polarity, as it increases, we will say about the compound that we have it polarized and will be polar compound. Okay. So if we will go to the periodic table, please check the periodic table that I just shared with you. So, but we will take another example. Let me open another page, which is, I will take it between hydrogen and hydrogen, and we'll see if polar or non-polar by example. Okay, I have here hydrogen. And this is the other hydrogen gases. And have another element which is HF. Okay. Can you just go to the periodic table and find for me the electronegativity? Electronegativity is a value. Each element in the periodic table has its own one. Okay. So if we will go to the periodic table for hydrogen, how much is it? 2.2. Some books, look, if you are using different book, you will find different a periodic table, you will find that hydrogen is maybe 2.1. Okay, so this is difference by 1, by 0.2, 0.3. It's okay. You will, from one periodic table to another, we will find that there is a difference. I will share for a few minutes just the periodic table and I come back. بسم الله الرحمن الرحيم. بسم الله مش عارفة ليش اليوم. Okay, it's okay now. Do you see it?
Yes.
Okay. Do you still remember when, for example, we studied about sodium? Do you still remember that we have studying sodium here 2311? So this 11 is the sodium. This 11 is the sodium. Are you with me? I am talking. Is it on or not?
Yes.
Okay, because I feel
Yeah.
I am talking with myself. Okay, so do you see this is sodium? It was 23 and 11, which mean A, if you remember, and this is Z, because we still in our first unit, we care about the mass number and the atomic number, and we will ask about it in our quiz and test. So because of this, I have to keep focusing about the atomic number and the mass number. So here in this table, we don't care about the mass number. But why we care a lot about the mass number, the atomic number, sorry. The atomic number is identity. You cannot move, you cannot go to any place here in Canada, for example, without your ID. Because everywhere you have to go, they want to check your ID. I have my health card, but most of the time they ask about all the time they ask about the driving license. So because of the number, the information. So this is the ID that sodium have to hold it from periodic table to another. We have to add different information. It's okay. So the different information here that we added for sodium is the electronegativity. How much has the power to be electronegative? Okay, but we said that sodium is positive. It's okay, it's positive, but has an electronegativity. Has electronegativity because what? Because it has electrons. As it has electrons, so it has electronegativity. Here, for example, you said this is R because they are negative. Yes, okay, because they are negative has high electronegativity. Some books will say about the fluorine 4. Okay, so it's different between 0.1, 0.4. This is the difference from one periodic table to another. Okay, so this number is the electronegativity. You will ask me, Miss, how I will know this is the electronegativity, not the radii, or I don't know, whatever the periodic table. It will be written here, the value of the electronegativity. So don't feel scared. So the abbreviation of its electronegativity. So electronegativity for hydrogen equal how much? 0.93. Okay? Did you understand? Electronegativity for phosphorus is 2.12. So as we go across the periodic table from left to right, what will happen for the electronegativity? What will happen for the electronegativity?
Yeah, more.
Huh?
More.
More. It increases. It increases. It increases. And as we go from down to up, what happened to the periodic table for the electronegativity? Here is 0.7, 0.0. Sometimes it's the same, 0.90. What is happening here for the electronegativity? So it also increases. It's from down to up, and from left to right, the electronegativity increases. Okay? So if he gave me some elements and said arrange these elements according to their electronegativity. So for example, he gave me potassium, he gave me magnesium, he gave me chlorine, carbon, oxygen. So it's as you see, they are arranged, because when I picked them up, I picked them from here to there. That's okay, I didn't mix them. So as you see, potassium is here. Okay, so his less electronegativity than magnesium. And magnesium less electronegativity than carbon. And carbon less electronegativity than oxygen. Okay, so electronegativity, as we are going up, increases. And as we go this way, increases. So how we are going to ask you in the test? We are going to ask you to arrange elements according to their electronegativity. We are going to ask you if this compound is polar or non-polar by using electronegativity. Or we will ask you, is it a covalent bond or ionic bond according to electronegativity? That one, okay, I am sure you still didn't understand it because we didn't practice. Okay?
Miss,
Yes.
so for the quiz or test, do we use the periodic table that you gave us or anyone that we have?
This one?
Yeah, so in that quiz or test, do we use this periodic table or the one that we already have?
Because our quiz today doesn't include electronegativity, so you have to use the one with you. Okay?
Okay.
But for other quizzes, okay, so we have to give you this and the test. I have, for example, to take up to add it to your test, to use it, or I have to ask you, please bring it with you, or I have to provide it. You cannot memorize the electronegativity. I don't know them. I will not ask you something I don't know it. Okay. I know that the electronegativity increases. I know around, I still remember that, for example, hydrogen is 2.1 or 2.2, and the fluorine is the maximum electronegativity. I memorize some of them, but I don't memorize the value. So I have to ask you. Okay? And there is another third types of a question. I will not give it today. I will give it to you later. For example, to arrange compounds, more elements. And I will give them nearer to each others. And here, for example, nitrogen, oxygen, phosphorus, okay, which will more nearer to each others. And I have to give you the hint how to know them. Okay. So now this is enough for us to know, because every time we add some, till the concept is more and more familiar. So now this is the electronegativity. You know how to arranging. You know how to find it in the periodic table. Okay, I will go back to my question. Is this compound polar or non-polar? I will give you two, and I want you to know from the electronegativity by using the electronegativity. Let's go back to. Anyone want to leave early today? Because
I will leave early because I have a test. I'm not sure if you.
you have it today, or you have?
No, for tomorrow.
Okay, at least can you stay till 9:30? Or it's
Sure, I'll see.
okay. Okay, let's see. Okay. I have here hydrogen and hydrogen, and here hydrogen and the fluorine, and both of them, as I see, non-covalent compound. Okay, so what we are going to study now, we are going to study if we have covalent compound, okay, or if we have ionic compound, ionic bond, and are ionic compounds for sure. If they have ionic bond, so they are ionic compound, okay? So that's good. But if I know it's covalent bond, I have also to understand, is it polar or non-polar? Okay. For the ionic bond, for sure, it will not, we don't say about it polar or non-polar. It's polarized. As we know it's polarized, but we have to check if the covalent bond polar or non-polar. Why? Let's see, hydrogen. We have different, and we have to depend on the electronegativity. I know the electronegativity for hydrogen is 2.2. I know the electronegativity for hydrogen is 2.2. Okay, and hydrogen here 2.2, and the fluorine is 3.9. Is this correct? If we go to the periodic table? Oh? Is this correct? Some books said it's 4. We don't. Here, hydrogen is equal sharing. I know that hydrogen acts as positive. It has a positive charge. But here also it acts as negative. So it's why we are studying it. Now we will study it in the electrometallic series because it has sometimes properties of metals. And here he acts as negative more because it's attached to each other's, negative and negative. How much is the sharing here? Who's share more than the other? Who gives more than the other? Is hydrogen this hydrogen or this? Look at it. This is sharing by 2.2. This is the strength of it, and this is the strength of it. So sharing is equal here. They have equal sharing. Okay, if they have equal sharing, so what about the difference in electronegativity? Difference in electronegativity. How much is the difference? Who can tell me what is the difference in the electronegativity here? If this is the electronegativity of 2.2, and here the hydrogen, the second hydrogen is 2.2. How much is the difference in electronegativity? How much is it?
0.
Yes, 2.2 minus 2.2 equals 0. And what about here? Hydrogen here will act as positive, and fluorine here will act as negative. Okay? So we have to see if, because hydrogen has properties of metals sometimes, because of it's a gas. I know it's a gas, but it has some properties of the metals. Because of this, she is in period number 1 with the metals, because it positive, acts as a positive in the ionic bonds. And here 2.2 and here 3.2. Is the sharing equal or unequal sharing? As you see, is it equal sharing or non-equal sharing?
Non-equal.
Non-equal.
Unequal. Who attracts the others? Who has the power here? Who say I am the big boss?
It's fluorine.
Very good. So you got it, alhamdulillah. So fluorine, so it attracts it to here. Do you see this is very important because this is show who is the one attracts the other. So hydrogen is attracted toward fluorine. Here positive and here negative. Usually when I have different balls, so my compound is polar. Okay, but let's see. Okay, this is how the difference in electronegativity. But sometimes it's equal different balls, but the strength is not this much. It's a stay non-polar because the strength is not this much big. I will give you now how to recognize it from the value. But let now just study the things that we know. The difference in the electronegativity is here 3.9. I always take the big. Okay, because of this, don't ask me why we start with this or this or this or this. No, we will start with the bigger. We just want to know the difference. How much is the difference? Is 0.7 or 1.7?
It's 1.7.
Okay. 1.7. Okay. Let me go to give you the rule. If difference in the electronegativity is less than 0.5, so my compound is nonpolar. This is mean my compound is nonpolar. Nonpolar. If electronegativity is between 0.5 equals 0.5 to 1.9, so my compound is polar. Okay, if electronegativity difference, sorry. Electronegativity difference. Now I have to say what? Who expect what I will write? Who expect what I am going to write? See, students, this is the most important number. Okay? Just memorize these two numbers. Okay? Less than 0.5 is nonpolar. More than 1.9 is ionic compound. Okay? Or did you understand it? So I want to know if my compound is covalent compound or ionic compound. Okay, I will know it. If it's greater than 1.9 is ionic. If less than 1.9, it's covalent. Okay. If it's less than 0.5 is non-polar covalent bond. If it's between 0.5 and 1.9 is polar covalent bond. Okay? Here, covalent. I know it's covalent, but I want to know if it's polar or non-polar. Did you understand anything? So we will go back to our question and now answer it according to what we know. Here, my answer is 1.7. 1.7. Is it greater than 1.9? No, it's less. So where I am? I am here.
I'll be right back.
What?
I'm just going to the washroom.
Yes, okay. Abbas, I am here. Abbas?
Yes.
I am here. So My compound is what?
It's Indo.
Indo?
It's-
Abbas, this is not endothermic, this electronegativity. We
Okay,
start,
okay, so just give me.
yeah, because if you were with us, you will know. We are talking about electronegativity. Electronegativity is not this much easy. Oh, and I want to remind you something, Abbas. We are now in the grade 11.
Yeah, I just remember I was mixing, sorry.
Yeah,
I
this
mixed
is
it.
the problem because you are taking 11 and 12 at the same times. You should take chemistry this term for 11, and next term you have to take it for 12. You haven't to take it at the same time. Okay? Where is Safa?
Yes.
Yeah, okay. Because Safa is the same situation. Abbas and Safa are you in grade 10? Yeah?
No,
Is this, grade 12. Is this right?
Yeah.
Anyone? Yusuf and we have another Yusuf, but you are not. Sam, you are in grade 12 also?
He
Sam?
went to the
Huh?
he went to the washroom.
Ah, okay. So I thought you the one who went. Ali, are you grade 12 also?
Yes.
Oh my God. 3 students. This okay. Okay. And I know they are different. When you go to grade 12, imagine it, call it another subject. So you can focus more. Call it medicine, call whatever. Because if it's chemistry, you will feel a little bit confused. Okay, so here, now again, Abbas, here this is 1.9. And we are studying the electronegativity. You were with us when we talked about the periodic table?
Yes, I was.
Okay, so here I found it. This is the electronegativity. Huh? The electronegativity of fluorine from the periodic table is 3.9, and for hydrogen is 2.2. I need to find the electronegativity difference. This is mean difference. Okay. Here, for example, when I say this is in grade 12, this is mean the difference in temperature. And
Yes.
here, this is the difference in the electronegativity. The difference in electronegativity is 1.7. So he wants me to know that this is polar. It's a covalent compound. I know HF, they are positive and negative, metal and non-metal. And I know when I have metals and non-metals, this is a covalent bond. Is this right or not? So it's very easy. I know it's a covalent bond. I don't need to find the electronegativity to know if it's covalent or non-covalent. He wants me just to ask me if it's polar or non-polar, because I have hydrogen, it's a covalent bond, and HF also it's a covalent bond. But he want to ask me, you have this covalent bond and you have this is a covalent bond. Is it polar or non-polar? Okay, so I found the electronegativity difference. This is 0, which means less than 0.5. So it's non-polar. Okay? And this is more than 1.7, which is between the area that make from it polar. Because he said 0.5 to 1.9 to 1.9, it's polar. If it's more than 1.9, it's ionic bond, so it's not. Okay? Do you understand anything till now? I want to give you a question and you have to work on it now. Because I
Sure.
will have to give you the type of the questions that we are going to study. And I will give you a question that I am not going to study to work on it now, but we have to work on it next time. But I want to show you it. Or we will leave it for another time. Okay. But just I have to give you another type of a question. Okay, so now Bismillah. Identify . Usually this question said this way. I want to ask you, did you copy the notes in page 1 and 2? Always, while I am explaining something, get the chance and copy them. For example, page number 2 is very important. This is here in this compound, we have to write just it's a non-polar covalent bond. Non-polar covalent bond. And here I have to say polar covalent bond. And if I ask you in the test, justify your answer by using electronegativity, you already justified it, but you have to say, because if it's between 0.5 to 1.9, it will be polar. And this is in between the numbers. Okay, identify now. My question is, identify the following. Identify the following. Compounds. You can copy in this time page 1 and 2 till I finish writing. Okay. The most important are the notes that you take with you. One of my students in the grade 7 told me, Miss, why you don't use this? Okay, I will use it according to him. He is right. By using electronegativity, the compound are.
Miss, I'm back.
Okay, welcome. If you have a question, let me know. Okay. We need to copy page number 2. So check it. If you have anything, let me know. Not they are compounds, that the one that we wrote down. We wrote part of the compound. Just the bond. I am writing just the bond that we are going to study. Later on, we will study the compound as a whole. Okay, and okay, that's all. Only my question. Okay, did you finish? We have 5 students, and I wrote only 4 compounds. No, we have to write another one. I have to add one. It will be an H. Okay, so let's start with whom. They are 4, okay? And all of you have to be included. Ali, do you want to start? You have to use the periodic table, okay?
Sure.
I want you to study the bond, this bond, not the compound, because when we have compound, this is the compound. This is, did you understand the difference?
Yeah.
Yeah. So this is here, we are studying the bond. And here I am studying this bond. And here I will study this bond. And then I will see the attraction, if it will be cancelled or not cancelled. Okay? Because for
Okay, so-
example, if I have CH and here CH, this is polar. This is polar and good. And this is polar. But this is equal to this. At the end, they will cancel each other's. Can you understand? So for the bond, when we studying the bond, if it's polar, this doesn't mean that my compound is polar. Are you understanding the big idea? Now we
Yeah.
are studying the bond, if it's polar or non-polar. Later on, in other lessons, and it mostly in the grade 12, you have to study the polarity of the compound. Okay, I think the those who are in the grade 12, they are now study it according to the structure of the molecule. So they have to know if it's polar, the polarity, and from there they will have to identify the structure of it. Okay. Yes, Ali.
So you want me to do what we did in the
Yeah.
page 2?
Yeah,
Okay.
we have. I want you to identify it for me, and I will write just your names, the attendance, and the observation. Attendance, observation, and the observation is in type of bond. By electronegativity. The example you got was an H. It's a kind of test. Ali.
Yes.
Yeah, I am just writing Ali, and I want to get notes regarding Ali. Okay, Sam Yusuf. Because I put 5 questions and everyone have to answer and I have to write some notes. Okay. Okay, you need to know the electronegativity difference.
I have a question. Do I put the 0.4 or just the 3?
You have to give me the value of electronegativity for each element. Ali, do you see this, the letter T?
T?
Yeah.
Okay.
Yeah.
Text.
Can you click on it?
Yes.
Okay.
And just give you the answer?
No, I want to see everything. We are not able all the time to use the letter T because it will take time. For example, here you have to mention that this is how much is it, and this is how much, and which one is positive and which one is negative. Okay.
Oh, yeah, okay.
And
So
then you have to find the electronegative. This is the third step.
okay.
Miss,
Yes.
I have a question. So on page 2, I'm copying down, and there's like a word like I didn't understand.
Okay, where? Show me.
I drew an arrow. It's covalent
This is
something.
covalent compound.
Oh, it's
I don't
compound?
need, I thank you for letting me know. And I said we don't need this times the compound. We are studying the bond. Okay? Thank
Okay,
you
so
for drawing.
I just write covalent bond?
Yeah, bond. Because I told you we are just studying bond,
Yeah, okay.
all the compound. Okay?
Yeah, okay.
Okay.
So if it's more than 0.5, it's polar,
No,
so then it's non-polar, right?
no, not it's. You go to page number 2 and see the condition to be polar. It's greater than 0.5. Who can help him? It's greater than 0.5. Yes, but what? There is another condition. This is greater, but maybe not polar. Greater than 0.5, but it should be what also?
1.9,
Less.
less than 1.9.
So my question should be here.
Also,
So do you still remember when we were kids in grade 3? Or even in another grades, when it's let me draw this line. When we have it open, and this is 0.5, this is not included, and this is 1.9. But when it's grade 7 and 8, and when we make it like this, this is included. When they teach us the inequalities, okay? So between 0.5, this is mean that 0.5 is included and 1.9 is included. So as the value is here, so we are okay. Okay?
wait, so basically this is 0.8, and you said here if it's greater than 0.5 and less than 1.9,
Yes.
it's polar. So this is a
Yes.
polar equivalent.
Yeah, it's polar.
Yeah, this is what I said.
Yeah, but I cannot tell you. Because you said it's polar because it's greater than 0.5. I said no. You have, because this doesn't mean it's polar because it's just greater than 0.5. Because what if it's 2? This is greater than 0.5. It should be in between this value to be polar bond. Okay? And you have to memorize the rule, all of it. Okay? That. Which one has more electronegativity than the other? This is the second question. Which
The N.
has more electronegativity? Okay? Are you okay, Ali?
Yes.
Do you feel now good?
Yeah.
Okay. So for the second question, Safa, you have to memorize your one and go. You have 4. I give you the chance to. It's not fair to choose. I will give you chlorine. Okay? Safa?
Yeah.
I open for you another page and you have to choose this and go with it.
Okay.
Yeah.
Just letting you know, I also still can't see the drawing option on my screen. They won't let me draw.
Really?
Yeah.
It's you still.
Yeah, I think you gave access to other people, and I'm not one of them.
No, I asked my son and he told me if others can access and you the only one you cannot solve the problem from your side. Let me ask him. Just I cannot fix just the problems. If any one of you guys can, I will give him access to my screen and can fix Safa. Just let me ask Malik.
Miss, I have a question.
Okay, sorry. Malik, go finish your and come. Okay, go. Okay, sorry. He has a Quran lesson at 8. He will finish and will come. So, Safa, you will stay till the last one, and we will start with Sam. Okay?
No problem.
Any one of you guys know how to fix this problem for Safa? Okay. Let we start with Sam.
Miss, I have a question.
Yes.
So you want us to find the electronegativity and which one is greater, right? Which one has more electronegativity?
No. Which element has more electronegativity? Be careful.
Yeah,
Which
yeah.
element has more electronegativity than the other? Okay.
Okay.
And you want to identify if it's polar or non-polar covalent bond. We are studying just the bond. Or
Yes, and
it's ionic bond by using electronegativity. So if I know the electronegativity for each element and I get the difference in the strand, okay, let me just
for the
okay.
final answer,
Yeah.
do we say just it's polar, or we have to say why it's polar?
What is the meaning of white?
No, so I said it is polar.
No,
So
polar
that's it.
covalent bond. Polar covalent bond.
Yeah, but like I don't have to explain. It's just my work there.
Yeah, you have to say
Okay.
polar covalent bond, and
Okay.
as you have to say as it between these two values, and we said this is a condition. Okay, because it's between 0.5 and 1.9.
Yes.
Okay.
Yes. Okay.
If you give me this is good, if you give me this is good. Okay, just I want to explain for you something. Here it's look like this. Okay, this is the power. Which one is more electronegativity than the others? Which one attract the other to its side? Here nitrogen is the one who attracts the other. Okay, but even they are not the same hands. Okay, my hands are in the same size. Which hand is bigger? As if you are playing with a boy, his age is 12, but 10, not mashallah. Some boys are 12 are big. So his hand, this is much small, and your hand like this. Okay, so you are holding him this way, and so you are the electronegativity, you are drawing him this way. Can you imagine this or not? For the size is difference, not both are the same, because hydrogen is one electronegativity level, while nitrogen has two levels. Okay, so the attractions of nitrogen on hydrogen is bigger. So the electronegativity comes from this. Okay, did you understand it or not?
Yes.
Okay, don't don't forget. Remember this. This is hydrogen, has only one here, one electrons. While nitrogen, look, this is nitrogen, has another one level, and inside it's two. And in the second, nitrogen has 5. Okay, has 5, and it take sharing with hydrogen by 1, and also share here by 1, and share here by 1. So it make forces in the 3 area. So it's attached this hydrogen to her side and attracts the other hydrogen to her side and attracts the other hydrogen to her side. So this is the power that she is doing. She opens the 3 areas where is making attractions for them. And she can. She attracts here the hydrogen, and here there is another hydrogen. She attracts her, and here there is another hydrogen she attracts to her. So do you see it's bigger than the 3 hydrogen? From here comes that the bond is polar, and this bond is polar, and this bond is polar. But what about the compound, all of it? Is it polar or non-polar? If we are going to identify it, even it's a grade 12, this polarity, if will be cancelled, will be this. At least this is will stay. Okay, so it's a polar compound because the shape. This is completely because we have to know the angle and the shape that it takes. Okay, but this here will not be cancelled. It has 3 powers. If we are able to cancel for her 2, we are not able to cancel for her the 3rd. So it will stay polar compound. But here we are studying just the polar bond. Was it clear or not? This is the step we are studying because we want to study later the polar compound, the polarity of the compound. Here we are studying only the polarity of the bond, each bond by itself. Okay, students? Okay, let's now with the Safa, no, we said sun. Yeah? Are you ready, San?
No, miss.
Yes. So we will give you, subhanallah, Safa question, because Safa, as long she will stay more, I am aware of this fact. So the mark that Ali will got
Yeah, okay.
not be at all as the mark that the fifth person got. Did you understand why? Because Ali, when he just start,
No.
you got information, and when the
Mhm.
second did, he got information. So not always we will start with Ali. Okay? But
Okay.
yeah. So San, you have to make better than Ali, because I have to give you mark different from him, because I will say you didn't listen to the explanation or to the notes. And as long as you are not the third or the fifth, or so your mark will change according to this. Now, sorry, chlorine. So
Miss, I'll be back.
Hmm?
I'll be back in 5 minutes.
Okay.
Miss
Batali,
Noel,
Batali, please. Try to return back while we are discussing some of them,
Okay, yep.
because you didn't do this much well. Okay, you just got got the concept and understood it. Okay.
Miss Noel,
Yes.
I have a question. So on page 2, for the ionic bond, is this like symbol like less than or greater than? I drew an arrow.
Just let me figure out what we wrote.
It's this one.
This is greater.
Greater? And what do we call it if it's greater than 1.9?
Greater than?
1.9. Do we call it like ionic?
Yeah, it's ionic bond.
Okay.
And this is greater. You know what is how to read? Do you know this? How to read this small or greater, or you mix
Yeah.
between them?
I kind of mix.
Okay. And
But for this one, is it like greater?
yeah, this is a greater. If it's greater than, I just usually make it. In comparison, it's very easy, but here it's small. It's greater than 1.9. Do you know? This is mean that the value is here, is bigger than the value is here. I will explain in the other page how I teach for my students for this in the elementary classes when we identify it. So when I say 2, please, many of us mix between, when we say 3 greater than 2, okay? Can you see this?
So it
So-
means 3 is greater than 2.
Yeah, do you see this, the distance between these 2 points?
Yeah.
And this is 1 point. Okay? Do you see? So this, the number who is here, greater than the number who is here. Can
Yeah, I
you,
understand. Yeah.
yeah, did you understand it?
I understand.
Yeah, I usually telling them, do you see this is big and this is a small area. So the number who is here is big than this. When I say greater than 1.9, so this is mean the value that I have it here will be more than this. This is a small. Okay, is it good? Is it?
Yeah, it's clear.
Yeah.
Thank you.
Yeah. So this is more for in math. Let's go back with Sana. Sorry, Sana.
No, that's okay.
Yalla, start. I am here, I am writing notes.
Oh.
Yalla, try, start. I am listening and writing my notes.
Oh, you want me to do the same Ali
Yeah,
did?
the same way. I want you to identify if it's ionic or covalent. And if it's covalent, you have to tell me if it's a polar or non-polar.
Oh,
Okay, I am listening to you, don't worry.
so it's not a metal? And it has, wait.
Okay. Just a minute. استنى شوي بس when this guy finish we will try to help Safa. Okay, just a minute. Let me write my note. He didn't do. Okay, very good. Show me
Yeah.
how you are doing it. Okay. When I see this, I will not understand it, to be honest.
No, 3.16 negative
No,
3.16.
not the value, not the value. But you
Then-
have to say you have to say electronegativity equal. That's okay. I accepted that you are not writing electronegativity like chlorine minus electronegativity for chlorine, but at least tell me no. If this is the real one, electronegativity difference equal electronegativity like chlorine minus electronegativity like chlorine.
Oh, okay. So I have to write the 3.16 here beside the,
Yeah, no, it's okay. Yeah. So now, delta En equal how much? 0.
Yeah.
And now, what you want to say?
it's not a polar.
Oh, non-polar.
Sorry.
Yeah. This is non-polar.
Yeah.
Why?
Because it's under the 0.5.
Yeah, because it's under 0.5.
Yeah.
Okay. It's between
Yeah.
0 or whatever the number. It's less than 0.5. Okay.
Yes, less than
Thank-
0.5. Yeah.
Okay. Thank you, son. Safa, are you ready?
Yeah, no problem.
Yeah.
Okay. Safa, Malik, please come here, Habibi. We will open another page. Your compound is CO. Okay.
Okay.
And we Mama دايما ما she cannot access. She cannot write. Can you help her if there is a way? Okay. Just give me my notes.
Safa?
Yeah, Safa. Safa, can you write?
No.
So who is helping you? Maybe I.
Are you using the mouse or touch screen?
It's a mouse. Laptop.
Oh. Did you select the marker before?
Yes, other classes.
Like the one for drawing?
Yeah.
مش عارف.
Hmm.
So what is the reason behind that? So the doctor would
No, doctor.
he's unable. عامل لي بروفيشنال بالكمبيوتر.
لا.
Susan. Okay, go. Okay. ابعت بس روح من عنده روح من هون خلاص. Okay, Safa. This time you have to tell me and I have to write. Other times you have your phone and I have my one. Okay? So you can just write and on a paper and just give me a picture, okay? In other exercises, okay, Safa? Safa, you got me?
Yeah.
Okay, so now just tell me I will work here. In other classes, you are able to write?
Yes, yeah.
Okay. Why you don't send message for Mr. Hussein? Just in chemistry, you cannot.
Yeah,
And you are the only one.
yeah, I thought it was like an easy problem to fix. I didn't think it was hard.
Okay. So, okay, tell me now about the carbon.
Carbon is positive,
Okay.
oxygen negative.
Okay.
Oxygen attracts carbon
Why?
because it gains.
The one that will, it's here, there is no gainer, no loser.
Oh,
Okay. Because both are non-metal. Non-metal and non-metal.
okay.
Do you see who are focusing with us? This is a non-metal.
Mhm.
We are meaning by it. So they both are non-metals, they share. But if I ask you why, it attracts because due to the electronegativity. The electronegativity of oxygen is greater than of carbon. This attraction because of this.
Yeah.
Okay. How much is for carbon? Use the periodic table.
Yeah, it's carbon 2.5,
2.5 and oxygen
3.4,
2.4.
3.4.
Okay. Is this correct?
Yeah.
Okay. Now what I have to do?
Now we do the subtraction, so it's 3.4 minus 2.5. And then it equals 0.9.
Okay. Okay. So now it's 0.9. What then?
It's called a polar covalent bond
Why?
because it's not less than 0.5 and it's not more than 1.9. And it fits between 0.5 and 1.9, so it's polar.
No, because it's not less, you said. No, instead of saying this way, we say because it between.
Yeah.
It's easy expression because it's between 0.5 and 0.9. Okay? It's in between.
Okay.
Okay, that's good. Now, Ali, Safa, San, they did good. We still have Abbas and Yusuf. Who wants to go first?
I can go.
Okay, Yusuf, go. Sorry if I missed you. What questions do you have? You have to go to the other page and bring the question.
Sorry, which page do I go to?
Page number 2, I think, or 3. No, here, 2. It's CH.
I don't see it on page 2.
It's in page 3, sorry. I will write it. CH. And Abbas, NAF. I think it's NAF. I think this is. 35, 0.35. Yusuf,
Yes.
is it polar covalent bond or non-polar covalent bond? And give me the justification.
Okay.
Yusuf, very good.
Yeah, I did it like here.
Ionic bond, Yusuf. Ionic bond. We are studying the bond only, okay? It's an
I think
ionic.
that's Abbas one. Mine is
Abbas, sorry. This is Abbas, the one sodium of, yeah?
Yes.
Okay, Abbas, sorry. Give me the reason.
It's
I see the reason, but I want to but I want to hear it or read it.
you need to know the reason of why it's ionic.
Yeah. How did you know? I didn't know.
It's bigger or greater. It's greater than 1.9.
Very good. You have to write
So
it.
okay, sure.
Delta En greater than 1.9. So it is ionic bond. Okay?
Okay, that's sure.
Yeah. And there is something missing here. Do you have to write it for me positive? You have to write it for me negative, and you have to make this. Sorry. You have to write it. This is here the positive. Okay.
Miss, I have a question.
Yes.
For the Yusuf's answer 0.35, do you care if we put 0.4 instead?
0.4.
Yeah.
Some books will there is a small difference. Okay, we will not talk about it, do you know, because some books, I don't know which periodic table exactly did you use, and there are small differences 0.1, 0.2, 0.3, but don't make it till 0.5, okay?
Okay.
And you are making it 0.05, which is acceptable. You are not making it 0.5, you are making it 0.05. Okay? So it's still small. But I want to be sure this is polar covalent bond. Who has any comment regarding Yusuf? Is this bigger between Yusuf? Is this greater than 0.5?
It's like in the middle of 0.5 and 1.9.
Okay, let us draw it. This is my number line. Okay, this is the 0 value. And here 0.5. And here 1.9. And here it's but as bigger. Can you put for me this value on the number line?
Yeah, sure.
Yes, please.
I'm not exactly sure, but it's like somewhere between like here.
It's okay. It's okay. But Yusuf, this is your answer?
Yeah, it's somewhere between there. I'm not
Okay.
sure.
I will ask you another question. Can you make for me the number lines by values of 0.1 as difference? And this is 0 and here 0.1. And complete it till number 2.2. Please. I don't need exactly, but somehow. This is 0.1, complete. Here, how much it will be?
It's going to be 0.2.
Okay, 0.2, complete. Complete. Here, yalla.
So I'm writing them down with like text.
No. Write it here, Yusuf. معلش. Sorry. Okay, can you stop? What is this? 0.4?
Yeah, it's 0.4.
And this?
0.3.
And this?
It's 0.35.
Okay. And where it should be?
I think I made a mistake because I thought it's like a whole number, so I think it's in between those numbers somehow.
It's here.
Yeah.
Okay. It's between 0.3 and 0.4. And my 0.5, it's here. Okay.
Yeah, okay. I'll just redo
And
it.
this is non-polar covalent bond. Non-polar covalent bond because it is less than 0.5. Okay.
Yeah,
This
okay.
is a mistake, a mathematic mistake, not a chemistry mistake, but it's just I will write my note and come back. Please copy the notes. Okay, all of you did well, except Ali, because the one that we started with him, and so I am sure that you get benefits from the explanation to Ali. Okay, so now Ali, you have to get your chance. Okay, are you here, Ali?
Yeah, I'm here.
Okay, so Ali, this is your question because I want really to move to another high, and I want you to explain it for me. This one, which is calcium and iodide.
Where is it?
In page number 6.
Oh, okay.
In the meantime, the others, please copy the notes and you can come to watch Ali now also. Okay, usually, okay, should change the value and we set this note. And
Yeah,
now,
to change it the bigger one first and then the second one.
you don't mind who is comes the first because we will write for the in our equation delta E. No, it's not delta E. This is delta. And here it's electronegativity for iodine minus electronegativity for calcium. That's enough to show which one I am using. Okay? So
Okay.
we write our equation and then we will start. Okay, now.
Okay, should I finish now?
You finished?
Yeah. No. I'm just writing if it's polar or
Yeah,
non-polar.
please, please,
Yeah,
because we are waiting for you.
Yeah. I'm done.
It's solar. I get confused. Here it's 1. Let me go back. Calcium is 1 and iodine is 2.66, which means the difference is 1.66. Yeah. So the difference is 1.66. So I know if it's 0.5 to 1.9. Okay, so this is in between, which is not applying the rules. Do you know? It's covalent here. It looks like covalent polar covalent bond, even though it shouldn't be in this area because calcium is a metal and iodine is a non-metal. Okay, so it's ionic bond according to what we know, according to the information that we have. I will check why this one behave oppositely. Okay, and we will see. You have to write this, but just this is your mistake, Ali. Your answer is correct according to the given, but it's not correct according to the fact of calcium iodide. Okay?
And why it's not correct?
Huh?
And according to the thing.
According to the table, according to your solution is correct. But according to what we know, that calcium is metal and iodine is non-metal, and they have ionic bond. So if they have ionic bond, it should be greater than 1.9. Okay, I will check why it behaves this way, if there is something in her behavior against the rule. Okay, now.
Okay, and like if I do this on a test, will I get the mark or no?
I will usually when yeah, for sure, because this is what you
Okay.
get. Because I said check it according to electronegativity. Now,
Okay.
I want to explain one last thing, and then we will go to another things. Here, this is my periodic table. As I am going here, my electronegativity increase. Okay, as I am going like this, my electronegativity increase. Okay, and there is another things we studied it last time, is the radius. If you stare the atomic radius. We said the atomic radius for hydrogen is 1. And as we going down, for example, nitrogen, sodium also in group 1, but it has more. So as we go down, the atomic radius, you know what is the radius, yeah? The atomic radius increases. Okay, and we have to know here the atomic radius, how it works. But the atomic radius this way. Okay, as we go this way, the atomic radius increases. Because we have, for example, fluorine 7 and here. So if we are going to arrange them, the atomic radius will be increases this way. Okay, so we studied the last time the atomic radius, and now we studied the electronegativity. And regarding the metallic or non-metallic character, we know as we coming here, we are more metallic, and as we go here are non-metallic. Is this clear or not? As we go here, it's metals, because group 1, 2, 3 are non-metals. And as we go here till the end, this more gases, so it's non-metals. Group 5, 6, 7 are non-metals. Group 2, 3, 1 are metals. So as we go here, it's more metallic, has metallic properties. As we go this way, it's non-metallic properties. So this is 3 trends we studied it regarding the periodic table. Maybe next time we will add only one more trend, which is about the ionization energy. Okay, and all are the same as electronegativity. Whatever we have more is electronegativity, the same but all the other 2 trends that we have, the same but as electronegativity. But we have these 3 have different ways. I missed it. Okay, I will share with you this one. It's very clear. Okay, but now you memorize these 3 enough, and the others I will add it soon, inshallah. Now, Abbas, can we still explain 20 or 15 more minutes before you leave?
Yeah, that's fine.
Okay, and then we will have a break 10 minutes, and after that we are come back to do our quiz. Okay, but I have to finish this part, which is type of a chemical bond, because we have it in our test, not a quiz. I have message from somebody. I will be right back. I am back. Okay, Yusuf, I saw this message. Welcome. Whiteboard, where are you? Okay. Bismillahirrahmanirrahim. This part is very easy, and just I wish you will understand it so fast. I cancel it again. I will go to chemistry grade 12, Brahmin Rawan. Brahmin. This is not the one. Okay. I didn't find the PowerPoint. I prepared it, but I missed it. I will explain without using it. And then after that, we don't need, but just try to figure it out. Try to understand on me so we can finish it as much as you have to identify what is the type of the bond. We are now in page number 7. Okay. And we mentioned this is one we was while we discuss things. And the most easy one, we have to start with it, the building. The building, do you know, when you are going to build your house or you have to, as some items, you build them, you put them over each others to get at the end one only compound. Okay, just one compound. This is your house. This is the window. This is the chairs. This is just the house. You have many pieces. Many pieces. So this is what we call building. And in chemistry, we don't use the word building. We use the word synthesis. Okay. So synthesis, when we have many and our product is only one. Synthesis equation, we here are identifying the types of chemical equations. So what is the types of this chemical equation is synthesis equation. Okay, I will give you example. For example, I have hydrogen gas plus nitrogen gas, always hydrogen and nitrogen in the gas state will give me an H3. So this is what synthesis, because I have only one product. Okay, and now if we like to break things, not to build, so we are making decomposition. Decomposition equation. This is what Israel doing now. So we have just one building and it's go into many pieces. And so as we have water, for example, and we make for it electrolysis, and we divided it into hydrogen and oxygen. So decomposition, you are break down. And we know that electrolysis, it's mean breaking down. Example of synthesis, photosynthesis. Do you know photosynthesis? Okay, do you know photosynthesis? Anyone remember photosynthesis? Is there a voice or I close it?
Yeah.
Okay. So decomposition. Did you understand the difference between synthesis and decomposition?
Yes.
Okay. It's
Yes.
the opposite of each other's. A plus B give me AP.
Miss, I can't see the screen.
It's number 7.
It's frozen. Like I can't go anywhere.
Close it and reopen. And let me know.
Like, do I leave the meet and join again?
No. It's just to close the whiteboard and reopen it.
Oh, I can't. Like, you have to do something. Like, I can't go
Okay,
anywhere.
so leave the meeting and come back because it's frozen from your side.
Okay.
Okay, so synthesis is the opposite of decomposition. Synthesis, we are building. Decomposition, we are breaking down. Okay, so when we are building, so I have many materials. I just put them over each other's when I am playing Lego. Okay, I did a beautiful house from the different pieces of Lego. So this is synthesis. And my little brother comes and decomposes it for me. So this is what we call it decomposition. Okay, so it's the breakdown. Okay, Yusuf, do you see the screen?
Yeah, I do.
Alhamdulillah. Yusuf, we didn't say anything. Just we said if we are playing Lego, so many pieces, I built a house. So this is synthesis, building. Okay. So from many, I did one. And decomposition is your little brother comes and they break it down. So this is, we call it decomposition because it's a breaking down what I did into one. Okay. My third type is displacement. Displacement. What is the meaning of English of displacement? Okay. What is the meaning of displacement? Displacement, place. This is my place. Displacement, this is mean I am changing my place. Is it okay?
Yeah.
So displacement, just simply like this. Here, there are two friends. These are two friends are very friendly with each others. Okay?
Miss,
Yes.
are you writing?
Yeah, I am writing on page 8 and I wrote on page 7.
Page 8?
Yeah, now I am in page 8, but before I was on page 7.
Yeah. Oh, I can't open the page 8. I don't know why. Oh, yeah, now I can see.
Okay, son, you have to know one thing about me. I am a visual person. Do you know what we mean by a visual person?
Yeah.
Yeah, I cannot understand without writing. I
Yeah,
have
yeah, yeah.
when even I am speaking, I want to just keep writing, because I
Oh,
cannot
sorry.
understand. Okay,
Yeah, sorry.
so always when I talk, this is mean I am right.
Yeah, okay.
Okay, so this is two friends, and they are good, and they are happy, and this is Mr. X, and this is Mr. Y, and they have a good relation, and things are good with them. And usually, maybe usually we hear a displacement. Usually it's metal and non-metals, ionic bonds. Okay, and so this guy came, and he new to the area, and he said, no, this is guy Z. Okay, he said, no, I have to stay alone, no friend for me, no way. So I have to make a break between these two persons. And what to have to do? For sure, Z is positive. So he will take the negative. He will be the friend of with Y. This is Y and this is Z, and now they are a friend, and X is lonely. This is displacement. This guy changed his position and now he is with this one. Okay, so this is how things went. Sad story. Okay, so if I have calcium, and in this way we have to depend on something, we call it I open camera again because I still didn't give it to you. And this is, I am writing okay, this is what we call electrometallic series, because I cannot say, for example, that AU or silver, this one Z should be stronger than X. Can you imagine this? He should be stronger. If he is weaker than X, he will not break the relation between them. Imagine it's a relation between real people. So if Z is weak, do you think she will be able to break this relation? Okay. Safa.
Yeah.
If Z is weak, can she break the relation?
Yeah.
No, if she is weak, can it break the relation between X and Y?
Oh, no.
No. She have to be stronger. She have to have good mind to make these people hate each others. And why? To hate X and love her. And say, no, now I want to be in relation with Z. I don't want to be in relation with X. So Z should be stronger. Okay? Did you understand the idea? If the opposite happened, there is no relation. It will not be able. This is, I will explain it later, but please keep in your mind that the electrochemical or the metals activity, the activity of the metal is greater in Z than X. Because of this, she was able to break the bond. Okay? So let me get an example. If I have sodium, and this is sodium came and found HCl. Sodium will say, no, they are happy, no way. So I will make them like this. I will break the relation between them. And I know sodium is positive. And hydrogen have as positive. And hydrogen has a positive. And the chlorine has a negative. So sodium will look at hydrogen or at the chlorine. Which one she wants? Which one she likes? Who can tell me? Yusuf.
Yes.
Sodium. When she are going to break the relation between H and Cl, what she want?
I think the H.
But what benefits will get from the H?
They're gonna be together.
Because they are positive.
Yeah.
They are repulsion. Repulsion force will happen between them. Positive never love each others. Positive never
they
did a relation between each others.
They go together,
Whom?
like the sodium and the H.
No. Positive hate each others. There is no relation between each others. Hate each others.
So it's gonna go with the Cl.
Yes. Positive loves the negative and make ionic bond. Remember this, write it for your note. Positive hates each others, make repulsion. Okay? And
Okay.
positive and negative loves each others.
Oh, miss, I have a
Yes.
question.
Yes.
So it's always positive and negative, and if it's positive and positive or negative and negative, it's not gonna be together.
No.
It's not gonna work.
No. Positive and positive, they are good with each other. Positive and positive hate each others. Positive and negative, they are good.
What about negative and negative?
Negative, they have good relation and a strong relation. They are covalent.
So it's only the positive and positive.
Cations, yeah. Do you know cations, the cats? The cats
Uh,
keep fighting. The cats keep fighting. Okay?
oh yeah, I know.
Cats keep fighting. They cannot, you put two cats together.
Yeah, like my cats.
Yeah, but you can put cat and an ion. Okay? They are good with each other. They play with each other. And if you put negative with negative, they also stay good relation.
Okay, thank you.
And before I was explaining for my students as what is positive are the girls and negative are the boys. And I stop it because, you know, different cultures, I cannot, yeah. And in Lebanon, we are more open. And I cannot, because I was saying, for example, positive girls usually don't make a transfer. They don't make a company between each others. They are even easy broken, their relations, something like this. And even girls, when they fall in love, they give all the love for the others. Boys, usually, when they meet, they make a good companies. They build a good company I'm not company of relationships. I mean, their friendships is strong. But when I mean company, I mean that industrial companies. So I was explaining that way and with explanations, and it was really connected good with my students. And the PowerPoint that I have it explaining this way about the heroes. For example, Brad was married from Julia Roberts, I don't know, or Angela Jolie, and he left her and went with her. So the couple is broken and they make exchange the wives. So I will show you the examples when we come back. It's just funny example, but it's keep in mind how life is going. Okay, so this is good, please. This note is very good. Take it. This one, okay? Cats doesn't like each other's. Keep it in your mind. Cats keep fighting. No relation between them. Okay, so when sodium wants to look here, she wants the negative, doesn't want the positive. And so this is what will happen. And sodium, chlorine, plus hydrogen. And we have to keep in our mind, sodium, to break this relation, should be stronger than hydrogen. If hydrogen good and know how to keep her husband, the chlorine, sodium will not interfere between them. Okay? So sodium should be stronger than hydrogen. Are you able to understand how things are going? So now we are going to that third. This is and always one will be lonely, because this is single displacement. We said we are studying displacement. This is single displacement, because look here, sodium was single, and this couple, she broke the relation between the couple, and she now sodium a couple with the chlorine. And what happened to hydrogen? She is single. Because of this, we call it single displacement. Okay? And we will go to the second type of displacement. Abbas, do you want to leave? Abbas?
Is it that possible for 5 minutes, maybe?
Yeah, take that. We will come back at 9 to continue this part and do our quiz. Okay? Is it okay with each of you?
Yeah.
Yeah, please, because
Yes.
yeah. Thank you.
Yeah.
You
Yeah,
can
I'm
leave.
fine.
Huh? Yeah, go all of you and return back at 9. I will make your test ready.
Miss, I have a question.
Yeah, I am listening to you.
So what is this letter? Is it W2?
Hydrogen. So I have very bad handwriting. Thank you, Yusuf.
Okay, I was just writing it down and I want to make sure.
Yeah, it's hydrogen. And all gases are diatomic. They are in nature, they cannot stay alone. Because her relation got broken. So her sister, her copy twins, come and she is with her now. Sympathy.
Yeah.
Abbas. Abbas, are you here? It's okay, he will come. Because he's the only one who wants to pray Salat
I'm here.
Okay, so I will continue, okay? So we did the single displacement, now we will make the double displacement. Double displacement is the same idea as the single, but you know here there is no stronger. In the single, we need stronger. And the double, we don't need stronger. It's just two couples. This is mostly at the school. This is very talk active guy, and this is very talk active guy, okay? And so the teacher has a test, don't want these two guys to sit with each others, and even during the lesson. So she said, and these two guys are really always quiet. So she asked this to come sit beside this, and this is to go. So just displacement. She asked this one to be here. Okay, and for sure, this one, there is no place for him here. So have to go and take the place of this guy. Okay, is it clear? Is it clear?
Yeah.
Okay, so I have calcium chloride plus sodium hydroxide, for example, who is ever her partner is still the same. So calcium have to go and sit here beside hydroxide. For sure, calcium is positive and sodium is positive. So impossible to cut with each others. So calcium have to sit between with the OH. Okay? So even she will not choose because calcium will fight with sodium. So calcium will sit with OH. Calcium will sit beside OH. And for sure, calcium is 2 and OH is negative regarding, okay. And plus sodium at 9:20, our tests have to start. It's already on there, but you cannot open now. Sodium chlorine, and that's all. And we have to do the balance. I don't, okay, is it clear?
How did the OH became 2?
Oh, Ali, you didn't attend the first class. Calcium has 2 plus charge. And OH minus have another 2 plus. This is.
Oh, so you switched them.
Yeah, this is come down.
Okay. Yeah.
For Ali, San, and Safa, if you didn't do well in the quiz, we have to redo because if you miss something. So we studied synthesis and decomposition. They are opposite to each others. We studied displacement, and we know it's double, it 2 types, single and double. And we have only 2 others, which is the decomposition, combustion, and the neutralization. We have only 2 others, combustion and the neutralization. Let's take the neutralization first. I will give you all this as example to study them. Neutralization, and please write now. Neutralization, it's mean acid plus base. We should have acid, and we should have base. And this is when we have a stomach acidity. We got base because acid with base, and they call it the base anti-acid when we have acidity in our stomach. And it will change into salt plus water. Because of this, we feel well. Okay? Sometimes it doesn't work. If we have high acidity and we got a small dose of base, we still feel the acidity. Okay? So if we have acidity in our stomach and we got anti-acid, which is a base, it will change into the acid and base will combine with each other to give me salt plus water. And we will get example. We will go to page number 10. The easiest example that we love and like is always HCl plus sulfuric acid. or nitric acid, or this the most famous acids. Okay, this is acid. Is this correct example? Student, look at it. This is correct example? No, for sure. The both are acid. Sodium hydroxide. This is correct example. I have OH and I have sulfate. Sorry. I am not the one who has the test. Why I don't feel when I have test, I don't feel well. Just I keep looking at the time. So, because at 9:18 I have to stop to let you go to the to open your class Google. Okay, so here I have the H. This is will make water. Okay, so this is together will make water. H and OH will make water. And then sodium is positive. And I know the H is positive. So it's a double displacement. It's a double displacement, but at the same time is a neutralization. Okay, so some students mix up and say this is double displacement. Yes, correct. This is double displacement, but even it's more specific. It's a neutralization because I have OH and H. Did you understand me? So this is double displacement because there is the changing. This come to here and this come with this. So this is and this is because it's negative. So sodium will come with it. And so sodium and Ali, do you see? This is 2 and this is sulfate. Do you know why? Do you know why?
Because you switch them.
Because sulfate is 2 minus and sodium plus 1. Okay. So this is my product and we call it a neutralization because the presence, when we have one compound has OH and the other compound has H, for sure we have a neutralization. Okay. Third one. The last one. Okay. Which is the combustion. And I will give you just one type of combustion now. We'll add it next time. Combustion is 2 types, complete combustion and incomplete combustion. Let me give both and then I will explain it more. Complete combustion, enough oxygen. Let me write it, complete. Complete combustion. What does this mean? Presence of enough oxygen. Please, for the handwriting, present, because sometimes the pen disconnect presence, and my handwriting is not this much wow. Presence of oxygen, enough oxygen, enough. The most important word is enough. Okay, and incomplete. Incomplete combustion. This is mean not enough oxygen. No enough quantity of oxygen. Okay. So this is, there is always with hydrocarbon. We usually give you the example with hydrocarbon. CH4 plus oxygen. It will give carbon dioxide. I will review this part on Friday before the test. Always this is the given. I don't give you the equation. I just say for you complete combustion of this. You have to know plus oxygen give me carbon dioxide plus water. Incomplete, I will incomplete for CH4. You have to know that it's also combustion. So in the presence of oxygen, but the product is carbon plus water. Sorry, not carbon monoxide. There are other products, but we don't care about them, which is carbon dioxide and carbon. Carbon is the black color at the bottom of the band. If you see, sometimes we see it's very dark, the band at the bottom when we put it on the fire. This is due to the incomplete combustion and the releasing of carbon. Okay, we will explain it more next time, but this is what we have to know. Okay, are you ready to go? Take your notes. We will work on these types of reactions, inshallah, on Friday. I will add for you a small hint also on the Friday before we start with our test. Our test on the Friday, it will be 1 hour and a half. I will give you more time. And now it's just 25 minutes around, or 35 minutes as maximum. Okay, from 9:20 we'll start, and you have to stop at 9:55. For 9:55, you will not be able to submit it anymore. So you at least 1 minute before. Are you understanding me?
Yeah.
9:55